Dear students, this session we are going to study about divided differences. Definitions. Zero order divided difference. The zeroth order divided difference of your function f with respect to a point xi is denoted by like this: f of in square bracket f of xi, and it is defined by f of xi equal to f of xi. So here zeroth divided difference is equal to direct functional values. Okay, that means given data. Definition for first order divided difference of f. The first order divided difference of f with respect to 2 points xi comma xi plus 1 is denoted by f of, again in square bracket, f xi comma xi plus 1, close the square bracket, and it is defined as follows, that is f of xi comma xi plus 1, right? So first leave the data xi, so we have remaining xi plus 1, put here, then put this value here minus xi, right? Similarly, leave this data, we have xi, put here and put the same data here, xi plus 1, likewise, right? Now definition for second order divided difference at the point xi plus 1 xi plus 2, at 3 points here, xi plus 1 xi plus 2, denoted by f of square bracket xi comma xi plus 1 xi plus 2, close the square bracket, is defined as follows, right? So here f of xi comma xi plus 1 comma xi plus 2. First leave this variable xi, so remaining we have f of xi plus 1 xi plus 2, right? Put the values here, minus, leave the last value here, that is f of xi plus 1, divided by the first variable left here is xi, put in the second, and second one is at the first, right? Xi plus 2 minus xi. Similarly, we can define the k minus 1 to divide difference, right? If we have k points like this, xi plus 1 up to xi plus k, then the kth order divided difference can be written like this: general recursive formula, f of xi up to xi plus k is equal to, right? Now leave the first variable xi. So what are the next point? Xi plus 1, right? From xi plus 1 to xi plus k, minus, right? Leave the second last variable, right? I mean last variable. So here xi plus k, if we leave this, right, from start from xi plus 1 up to its previous term is xi plus k minus 1. Okay, then put first value here in the second here, and second last value in the first, that is xi plus k minus xi, right? Now the divided difference table. So now we are going to construct divided difference table, right? So take 5 points here, 6 points here, x0, x1, x2, x3, x4, x is at the xy at the first column, corresponding functional values at the second column. Okay, now we are going to find the first divided difference, right? Take first 2 points. Okay, it is f of x0, x1. So can directly easily find this f of x1, difference between these two, f of x1 minus f of x0 divided by difference between these two, xn minus x0. Okay, now for this value, right, f of x1 plus 2 equal to, take the difference between these two, f of x2 minus f of x1 divided by x2 minus x1, right? Similarly, difference between these two, f of x3 comma x2 equal to f of x3 minus f of x2 divided by x3 minus x2. Likewise for all the remaining divided difference. Now how to construct for second order divided difference? Okay, so these are all now first order divided difference, right? Now we are going to find first second order divided difference, x0, x1, x2. Okay, take difference between these two values, right? F of x1, x2 minus f of x0, 1. Then take difference between x2 and x1, that is x2 minus x1, leave x1 here. Okay, similarly for the second value, f of x1, x2, x3. Okay, find difference between these two, then take the difference between these two, x3, x1. Now leave x2 here, x3 minus x1. Okay, likewise for remaining difference. So here is the complete table for dividend difference of n equal to 4 here. If we take 5 points here, with the corresponding function value, we can find dividend difference like this. This is first order dividend difference. This is second order dividend difference. This is third order dividend difference. This is fourth order dividend difference, right? So here is an example, right? Now an example here. So here given function is f of x equal to 1 by x. Then find the dividend difference of f of a comma b, f of a comma b comma c. Okay. So given function is f of x equal to 1 by x. So first we are going to find f of a comma b, right? Or f of a comma b, the formula for this is f of a minus f of b by a minus b. That is equal to f of a equal to simply 1 by from this argument. Okay, f of b is equal to 1 by b. Take LCM here, cancel common term a minus b, we get minus 1 by ab, right? That is f of a comma b is simply minus 1 by ab. We need f of a comma b comma c, right? So formula for this is f of a comma b minus f of b comma c divided by a minus c. Formula for f of a comma b here is minus ab minus 1 by ab minus of bc is same thing here, minus 1 by, instead of ab we are going to put bc here. Now simplify this, we get 1 by abc. So f of a comma b comma c is equal to 1 by abc, right? Now points to remember. So these are some important points here. Each divide difference can be obtained from two previous ones of lower orders. Okay. For example, if you are going to find the second order divide difference, f of x0, x1, x2 can be computed from f of x0, x1 and x1, x2 and so on, right? So if we need second order divide difference, we first we must complete first order divide differences, right? Note that in computing Pn of x, that is polynomial, we need only the diagonal entries of the above table. That is, we need only f of x0, f of x0, f of x1 and so on. That is, for example, say this example, if in formula we are going to use only this value, okay? We are going to take only this value, f0, f of x0, x1, x0, x1, x2, x0, x1, x2, x3, like this, right? Okay. Now third point, since the divide difference are generated recursively, the interpolating polynomials of successively higher degrees can also be generated recursively. Thus, the work done previously can be used. Now example, how to prepare divide difference table. Prepare a divide difference table for the following data. So here x value is given, y value is also given. Okay. First list the x values like this, then list a function value like this. Okay. Now we are going to find first order divide difference, second order, third order. Okay. First take difference between these two, divided by difference between these two, that is 0.620 minus 0.765 divided by 1.3 minus 1, we get this value. Similarly for these two values, 0.455 minus 0.620 divided by 1.6 minus 1.3, we get this result. Similarly, take the difference between these two, 0.281 minus 0.455 divided by 1.9 minus 1.6 is equal to minus 0.578. So this is the way to find first order divide difference. Similarly, we can easily find a second order divide difference. Likewise, take difference between these two divided by difference between these two, 1.6 minus 1. Okay. Similarly, take the difference between these two divided by 1.9 minus 1.3. Okay, not 1.6. Right. Now for the third order divide difference. Okay. Take difference between these two, minus 0.049 minus of minus 0.108 divided by 1.9 minus 1. Leave two datas here. For second order difference, we leave one data in between data. Here we are going to leave two data. Likewise.